हेलो स्टूडेंट्स, कैसे हैं आप लोग? आई वेलकम यू टू दिस कैन यू सॉल्व इट सीरीज। आपको पता होगा, इफ यू रिमेंबर द लास्ट क्वेश्चन ऑफ इनइक्वालिटी सीरीज फ्रॉम कैन यू इनइक्वालिटी सेक्शन ऑफ कैन यू सॉल्व इट सीरीज, इफ यू रिमेंबर वी प्रूव्ड Cauchy-Bunyakovsky-Schwarz inequality, or which we also call it as Cauchy inequality or CBS inequality. What was this inequality? It was that, let's say, if you have n pairs of numbers like a1 b1 a2 b2, you have n pairs. So if you multiply each pair like a1 b1 plus a2 b2 plus a3 b3 up to an bn, and when you square their sum, that will always be less than or equal to a1 square plus a2 square up to an square multiplied with b1 square plus b2 square up to bn square. So you know that the right hand side would be greater than or equal to the left hand side, and we proved it for all the real numbers. Now there you see the inequality. Here you see a slack inequality. What is slack inequality? You see that it is greater than or equal to. So it means for some values it is going to be equal. So what the idea of asking this question is, at what condition or what should be the relation between a1 b1 a2 b2 so that this inequality becomes a equality. That is what we mean when we say find the condition of equality for Cauchy-Bunyakovsky-Schwarz inequality. So let's see, if you remember the proof, how did we proved it? You remember we created n quadratic expressions. If you remember it, we first started with a1x plus b1 whole square plus a2x plus b2 whole square, and it was going up to nth quadratic equation in quadratic expression anx plus bn whole square, which we know that this is going to be a polynomial, 2-degree polynomial, and we know that this first quadratic will always be greater than equal to 0, the second one will also be greater than equal to 0, the last one will also be greater than equal to 0, and each quadratic expression would be greater than equal to 0 because they are perfect square, which itself speaks that the whole polynomial px would be greater than equal to 0. So equality happens at 0. So what should be the condition when each quadratic expression should become 0? So definitely you know a1x plus b1 should be equal to 0, a2x plus b2 should be equal to 0, a3x plus b3 should be equal to 0, and similarly anx plus bn should be equal to 0, which implies x1 should be equal to minus b1 by a1, which implies the x for the from the second quadratic it should be minus b2 by a2, and similarly the nth one would be minus bn by an. But what we want is they all become 0 at the same time, which means all the roots should be equal, which speaks like minus b1 by a1 should be equal to minus b2 by a2, should be equal to minus b3 by a3, should be equal to same ways minus bn by an. So you can say, if you have the pair in the same proportion, like a1 upon b1 equals a2 upon b2 equals a3 upon b3, in the same way every term with till nth term they all share the same proportion, then we can say this Cauchy-Bunyakovsky-Schwarz inequality will become equal. That is the condition of equality. I hope you understood it.